Four, three, two, one. Okay. Hello and welcome to Proptech Buzz, a global platform for proptech and construction tech products and leaders from around the world. In this podcast series, we talk to founders, CEOs, innovators in the construction tech space to learn from them how they build and grow successful companies that revolutionize the proptech industry. Before I introduce my guest, I encourage all of you to subscribe to our podcast channel and join our PropTech community on proptechbuzz.com, where we share a lot of valuable information and insights in PropTech topics. I'm so happy today to be having one of my heroes and mentors, one of the pioneers in the Middle East in the field of construction informatics. Um, Ahmed Zaksouk is one of Egypt's top senior solution architects that worked on Autodesk and he dedicated a lot of research in the field of construction informatics. He has a lot of wealth and experience in developing innovative solutions for the construction industry. He focuses also on integrating advanced technologies to enhance construction processes, to enhance the efficiency and sustainability of construction buildings. His expertise in both practical applications and academic research positions him as a leading figure in the intersection of construction technology and research. I believe he will provide us today with a very unique perspective and approach to both academia in the field and real life scenarios. Okay, so hello, Ahmed, welcome.
Hello, Ahab. Thanks for having me today. It's
Yeah,
my
yeah.
pleasure.
It's the pleasure. The pleasure is totally ours. Okay. I give a little introduction about you, but I wanna hear from your perspective and from your point of view. Can you share with us a little about your career journey and what led you to the current role that you are in?
Yes, sure. Let me share my screen so that I can give you some insights on myself. So I hope you can see my screen right now.
Yeah.
My name is Ahmed Zaksouk. Work as a
Yeah.
senior solution architect at Autodesk in Germany.
Yeah.
And I'm
Mhm.
also PhD researcher in construction informatics at Dresden University of Technology. I'm based nearby Frankfurt in
Yeah.
Germany. So my career path was a little bit, during my start, there were some science during the bachelor phase. So basically, my wish was to study computer science from beginning. But in Egypt, we know the tradition engineer versus slash doctor wish
Yeah.
from parents. So yeah, I ended up doing architecture, but was very keen to do or shift on the postgraduate level. So basically, I heard about the Information Technology Institute scholarships in Egypt. And they offer various programs in IT for in a postgraduate phase. So, and when I just graduated, there was a new intake for EEC informatics or construction informatics. So yeah, I decided to join, and it was really insightful 9 months. It was very intense. So at that time, it was like it's equivalent to 3 semesters. Yeah, of intense IT study because basically we were able to continue just writing a thesis at Nottingham at that time, and you could get a master's degree
Yeah.
so in IT. But yeah, so it was the beginning of jumping into BIM software development, JIS development, and so on. So we did various courses, in programming fundamentals, and C and data structure. Then we moved to advanced programming with C sharp, and then we focused on BIM software development, basically with AutoCAD, Revit, APIs, Autodesk products customization. And then we got also some JS for courses from Esri. So basically, ArcGIS customization and development and so on. And of course, we had also some computation engineering, like finite element, linear and nonlinear, and we had also scientific computing optimization on, and that was also very, very interesting part in the program. And then we dived into web development and cloud applications development. So basically front end and back end development, and that was in 2014. So I graduated in 2015, having both web development, desktop development skills, and of course ITI is very popular in Egypt. So we get also the chance to get hired even before graduating. So I had participated in one group graduation project and one individual project. I did. It was kind of like a Revit plugin. The individual one and the group one was kind of like a web app that integrate BIM and JIS, and that was 2015. And these terms was like hyping in research, but not in industry much. I mean, now we have Esri GeoBIM, and we have a lot of products integrating BIM and JIS and so on. At that time, I was like, okay, let's. When I was studying, and of course, during study, we give more focus also on open source technology. Like at the time I integrated XBIM, for example. It's kind of like BIM viewer and Cesium, so which is an open source GIS viewer, which is very powerful, even used by NASA and so on. Yeah, and that was in 2015, and I never thought that this development will go crazy. And the challenge was that the companies don't know you, or they don't know the program. They don't know who is an EC informatician can do, or a BIM software developer. At the time, it was like, okay, you're an engineer. Maybe you're a BIM engineer. Okay, we know that, but yeah, it wasn't clear, and that was the challenge of how you could introduce that. To the target companies. So, but luckily, I got an offer from CCC, which is a big contractor in the Middle East, as a BIM automation engineer. So, and forget about the Autodesk portfolio, because I learned to do ecosystem customization, Bentley stuff. So, because CCC was one of the only companies that uses Bentley products. So that teaches me that a programmer or a developer is not meant by technologies, meant by the logic and the design thinking and how to divide and conquer problems. So then I started my journey with CCC as a BIM automation engineer. And yeah, since I was in high school, I was a little bit I did German as a foreign language. And I was fascinated about the country, and I wanted to go there to visit the country, and I know it's in the industry, it's very strong and so on. So in 2016, I decided I was applying for workshops and so on, and even in the bachelor phase, we were doing some workshops was in collaboration with other universities and so on. Yeah, and then in 2016, I got the chance to join an international workshop in Stuttgart. It was about space station design, so not much related to maybe BIM and EC tech. But the good thing that I was a visualizer, I was accepted in the visualization role. So it was like, okay, we are two teams. Each team is 20 people. We were like from everywhere in the world. MIT, there was everyone from Australia, from every side of the world, and I was responsible for the visualization. And I think my experience in BIM was the reason that I got there. And the funny thing that I tried to use my BIM skills to visualize the construction of this space station. So we were like 20 people from communications, robotics, every domain. And I was like, okay, I'm gonna use now my BIM skills. So I did like 4D, 5D simulation of how the space station is being constructed and so on. It was good, funny, enjoyed the experience. Came back to Egypt, was trying to come back. I wanted to continue my career in Germany. So I started to apply for jobs, internships, and so on. And then I made it by Hochtiefweicheln, 2017. I started as an internship in BIM, as a BIM software intern. BIM software development intern, and then I got full-time job by offer by the company. I then continued. Basically, I was doing customization of engineering softwares, different systems. Also working database side, backend, front end, and most of the work were like Autodesk products customization, Revit customization, so on. But at some point I realized that working as a software developer in construction companies is totally different than software companies. And if I want to grow, to reach somehow on Autodesk, because that was a goal for me when I was in Egypt 2014, when I decided to study construction informatics. So to join Autodesk, I said, okay, being in a construction company might get you there, but it's not the best. So let's get a EEC software provider experience, and that's why I joined RIP at that time, 2018, when I joined the i2 4.0 team. It's a cloud product for enterprise BIM application for 4D 5D simulations. And there I worked in the in the 5D BIM team. We're responsible for the viewer integrations with other modules, like worked on Minimap viewer, worked on different viewer functionalities, integration, model versioning, and so on. And it was a really great experience to be mentored by someone who is my team leader was a PhD in computer science. And I had also another senior, the product manager was someone who is 15 years plus in BIM. That's good to learn from him. But I was mentored by my team leader, who is a PhD in computer science. I was in construction companies, of course. I was also mentored by great developers. But the team is not big. In construction company, maybe you have 4-5 people working. That's maybe a very good number working on software customization. But I was in a team of 30 people. Our small team is 5. It's still a good number to be mentored and so on. And I was learning, in construction, we care more about production as scalability, performance, stuff like that, documentation, and over. So in RIB, I learned how to be a professional software developer. It's not more just having the programming knowledge and just type something and it works. No, it's not like that. You may take more time to develop, but you need to care about different things, performance, and so on. You get to have one task maybe for 1 week. It depends, of course, on how big is this task. But the idea here is that it's not just making it works, it's just to make it sustainable. So I worked for a couple of years, and I have learned a lot of knowledge and experience. Again, also good experience in software development. At the time I worked basically was the library called Hoops. So it's got something like also Autodesk platform services. You can have a BIM viewer on the cloud and so on and so on. And then yes. You want to say something?
That's very inspiring, fascinating story, and it's a bit inspiring how you started dreaming about being in computer science and then moved to construction, and then you merged both of these together and working in computer science and software development and construction. And after that, as not expected at all, that you work on a spaceship project. So life really is a journey that we don't know where we are going. So I also know that you recently founded a company that's called BIMbrain. Can you give us a bit about this creation and what inspired you to create BIMbrain, and what are the challenges that you faced creating it, and especially can you give us a brief about what are the problems that BIMbrain's trying to solve, and what are your solutions to these problems?
First of all, I'm doing my PhD next to my full-time work. So I'm researching in Dresden University of Technology in construction informatics. I'm currently in the third year of my PhD. And BIMbrain is just, founded because of the product of my PhD. So in my PhD research, I've been working on, brain-controlled smart homes. So basically, giving the opportunity or the chance to people with disabilities to control their smart homes just with their thoughts, but not only people with disabilities, but also to provide for everyone luxurious way of smart home control. And basically, in the first year of my PhD, I was kind of like lost the normal. So I was like, okay, I wanted to work on digital twins, but I don't know what to do basically, so I wanted to work on digital twins to research for adaptive performative building envelopes. That was my PhD topic. And I was like looking and reading papers and so on. And I was fascinated by the bioinformatics field. It's where medicine come along with technology. Um, and especially the field of brain computer interface, where
Yeah.
people try to read brain signals, decode them, understand the brain. I was already amazed by the research and development in this area. And they have been doing a lot of great stuff, like giving people ability to move a robotic arm or robotic leg, for example, or even to move a wheelchair just by thoughts, and even robots. So I was kind of really amazed, and even the development on lie detection, how to see if this person sitting there is lying or not. So it was, oh, that's cool. Why we cannot use stuff like that in our domain? And I said, okay, what can I do to bring that to my domain? And I said, okay, maybe why not controlling a smart home just by EEG and or
Mm.
brain signals? And I found that I'm not the first to do it. There
Yeah.
are also many researchers has been trying to do so. Even in US and China, there are a lot of research in that area. By brain controlled smart homes and so on. uh, but what I'm giving is special because my with my knowledge at Autodesk,
Yeah.
and working developing custom solutions based on Autodesk platform services, and also customizing our Autodesk products, building solutions for our EBA customers. So I gained a lot of knowledge in web development, solution design, and so on. And I said, okay, digital twins can control a smart home. I can develop a digital twin system. Why not bringing post technology, digital twins, and brain computer interface along together to give people this possibility? And I started, okay, to build a prototype. As you see, the smart building behind me, this is the physical model where I have done my experiments with it and so on. And I put the EEG headsets, or also the VR headsets, and as also to know that I'm doing it as external PhD student. That means that I'm not hired by the university, so they cannot also finance me much. So
Yeah.
I'm self-financing that myself in my study, in my hardware, and so on. But I'm happy with what achieved so far with my PhD research. I have two publications, patent in progress. I have also two awards, one on African level, one on a German level. So yeah, I thought then, okay, let's have a company, and to put the IP on it, and to maybe get some funds some point, and to grow the business. So the company at the moment in the early stage, starting looking for incubation programs, so on. So and of course looking to scale this up, in the near future. So that's the idea, or how BIMbrain came to life. Yeah.
Yeah, yeah, that's very fascinating. And uh, you also mentioned to me that area that you have like a little demo from BIMbrain to us that you can show.
Yeah,
Can you give us a brief about that? And
yeah.
I'm so
I
excited
have
to see it. Yeah.
a beach video. I hope I can. Let me try to share to you, and also, yeah, I can share some slides as well. So let
Yeah.
me first share the screen. Okay, entire screen, and then I need to share the audio as well. To share audio, share tab.
Yeah.
Okay, to share a tab instead. Okay. I need to share a tab instead of an entire screen. So let me check. Okay, I have the intro.
Yeah.
Just 1 second. I'm uploading the videos so you can also share. But while I'm uploading it, yeah. So
Yeah.
basically,
Yeah.
it's going to
Mm.
be a 90 second, just to give you an idea,
Yeah. Yeah.
the pitch of the company. Yeah. Mhm.
Yeah, can also take the chance to ask you a couple of
Yeah.
more questions about the coming trends in the um, computer science in general, and how we can integrate it in the construction field. Of course, the revolution in natural language processing and AI, machine learning. How can you see that transforming the construction industry in the near future?
So the development of technologies in AI in general, we have seen natural language processing evolving the last 15 years. I remember, the first voice interface program I was like trying to test 15 years ago. You need to train the system on your voice. It gives you some sentences, and then you try to speak them up and so on, and
Mm.
then you're gonna get the opportunity to that the system can recognize your voice, and then later on you can also write, and it detect automatically your voice. Okay. uh, and this has been developed rapidly. We have seen now the development of Alexa and so on. It's quite impressive how quick this technologies went. So, reading your voice and recognizing anyone voice, because of the development in the AI and the machine learning, we have been able to detect far quicker the voices and so on. And we have been now using this in smart home control as well. So everyone, probably most of the people now have Alexa at home. So, and it's quite impressive, that you can just connect it with your smart lamps, smart devices, and so on, and it just work. So that's
But do
really.
you see it? But do you see integrating it with some parts like that was mainly done by humans, like architecture and architecture design and structural design, especially, and also like shifting the documents to the state to the execution part, and during execution that some robots are being used. How we can integrate AI in that field? Do you see that? Do you see us going this road, or we were just a trend that's gonna take like 1 year, one more year, and then it's gonna stop?
I think it was this speed of AI development we cannot predict easily the 10 years from now. But I do believe that the technology going to, the development will continue. And the EEC tech, or the EEC tech field will witness a huge development in the next years, because of the AI wave. And we should better be prepared, because AC is not the best in the digitalization wave. So we still
Yeah.
a bit step back from other domains. Uh, which might give some good time for many people to relax, but
To
it's not.
prepare, yeah.
The wave is coming, and you better be prepared now, because as you may see that I see it as the industrial revolution, where people in agriculture try to adjust and adapt to new jobs, and it's happening now. Maybe 10 years from back, I decided to do computer science in the postgrad because I love programming. I wanted to do this since childhood and so on. I have a long story about that, but it seems it's not far more option. If you love architecture, if you love being civil engineer, if you don't know how to write some code to an extent, or to use AI tool to an extent, the competition is going to be very challenging for you. So that's what I do see from my point of view. Yeah.
Yeah, that's very impressive and very fascinating insights. So, is the demo ready for us?
I uploaded the file. I don't know if you could already see it. It's yes. I hope the voice.
Excuse me, sir.
Yes.
But what would happen if, for some reason, we ignore somebody unlocked 100% of the cerebral capacity?
100%?
Yes?
Oh,
Yeah.
that's very fascinating. Yeah, yeah, yeah. So the people who didn't catch that, I think what happened there is that Ahmed there just thought about opening the window of the physical model that he has, and the window opened by itself. So that's very impressive, and very fascinating. Can you give us a brief about how do you achieve that, and what are the challenges that faced to
Yeah.
achieve that?
Sure.
Yes.
Let me just share my screen.
Yeah.
So give the audience some intro about that. So basically, our vision is to revolutionize smart homes with brain control technology to empower people with disabilities and provide everyone luxurious lifestyle. And basically, I just before explaining this, I just want to give the audience some idea about the domain. So basically, to control a building, we have a direct building control. This needs a human in the middle. Autonomous, which is totally machinery. A computer system take care of that. Semi-autonomous control, which is hybrid. Where, of course, you need both a computer system and you need the human. Human in the middle. What are the interfaces to control a building component as a human? So we have different interfaces. We have the manual interface. You go there, open it with your hand, the window, for example. We have a button you need to click, or we have a remote control. So that's it. Sensor, if you have the sensor in your garage, like you go there, it sees you, it turns on lights and so on. Authentications, okay, this is like the fingerprint that open door or something. You have the voice interface like Alexa, Google Home. You just speak, and it recognizes this with natural language processing and convert it to a command that you can control at home. You have the gesture interface, which is based on the camera. The computer can understand your gestures and transfer that to a command that you need to control a building. Again, the physical that involves maybe moving some machine or some button or something like that. And the brain interface. Okay, the brain interface is basically reading your brain signals and training the system to recognize your brain signals. But again, what are the brain signals and what you need to think of? That's the question that we are going to answer in the next slides. But just to give you an idea. So these are the photos of the different, okay, the direct control. Okay, we have the manual here. Okay, you need to open it with opener, whatever. Here we have the gesture. The computer started, the revolution of AI that makes the computer able to imitate that he can see and can hear us, understand us. And now the thing is, okay, we have the gesture interface, which is based on the visuals and the camera. And it's using image processing and AI. And the voice interface, which uses natural language processing, which has been 15 years different from what we have now because of the big data and the machine learning and AI development. And now what is going in the research is the brain-computer interface. And most of them are using similar approach, which is supervised machine learning. It's like, okay, the computer hear you saying, hello, my name is Ahmed, for example, okay? And you tell that the computer that you pronounce my at this way and hi this way and this way. And then from this, you need to feed him like thousands statements from your voice and what is the equivalent of them. And it will start to recognize your language. And imagine that we have 10,000 of sample data or maybe million sample data. And that's what Alexa and Google Home make use of, the thousands of data that are available for people are talking and also the results. And this is called supervised machine learning. And then you can train the system to recognize these statements. The same is in brain-computer interface, but of course, brain-computer interface involve another challenge: how to capture the brain signal first.
Yeah, exactly.
Yeah, but it is the same idea. And the good thing, okay, of course, there are different brain-computer interfaces technologies, but the most popular one is which one that uses the visual cortex. The visual cortex is the part which is responsible for imagination, and it's when you imagine, for example, a cube moving to the right or to the left. I'm just giving an example. You produce specific pattern of brain signal.
Yeah.
So this imagination process produces somehow a brain signal that you need to train the system for it. Okay, when I imagine moving to the right is like that. You need to train the system multiple times. Okay, when I think moving to the left looks like that, up and down. So you can train some mental commands with the, using supervised machine learning. And then whenever you imagine, again, moving to the right or to the left, it's going to recognize that signal. And then comes the development job, now how you could use this mental command to control some objects in the physical world,
So basically, if someone has like difficulties on imagination, so if someone like an artist or a graphic designer or an architect has like a better imagination, would it be easier for him to train these models specifically for his requirements?
Yeah, I mean, of course, people in imagination have different, let's say, metrics, and of course, your signal pattern is not like someone else. The idea here is to train the system on your pattern. It's not like there is a good pattern or a bad pattern. It's like, okay, we need to train. The consistency is the right way, and of course, the noise or the neutral state, because okay. Because your head can think about anything. What I need to do as a system. That's why we train the neutral state. Train your system to recognize your default brain signals, so that whenever you think, okay, I will not do anything because this is the neutral state. As soon as you imagine the mental command that we need, then I can take that command and transform it to a control.
Yeah. So basically, it's not like one size fits all kind of thing. It's like it's not like there is a signal for opening the doors or a signal for opening the lights or closing the lights. It's like what you mentioned earlier about training the how the models can track your voice in the natural language processing part. So basically, it's adjusted on every individual to track. Well, this signal is given the order to maybe open a window or to close the light, or maybe open the refrigerator or something. So and then we map these orders to these objects. Am I correct?
Yeah, basically you can map the mental command. I'm gonna show you the process and so on. But
Yeah,
basically, yes, if I you train movement to the right, you measure movement to the right, you can say, okay, this is open window, this is closed door. You can map this, but the problem is with mental command, you need to know also the hardware about the brain computer interface hardware. So I'm using EEG. Let me also give an idea about the brain computer interface basically. So there are different technologies. There are the non-invasive and the invasive ones. And the neural link from Elon Musk, they are working on the chip that can be planted and read directly the neurons. To imagine how big this could be, I am using an EEG headset of five sensors. Five sensors that the brain headset you need to wear on your head, and it needs the sensor be have a little bit skull contact, and it's five sensors. And
yeah,
there are this costs like 500 euros, but you can invest more to get like 12, 24, 36 sensor headsets, which will have better resolutions. When we have Neuralink, we could have like thousands, because the resolution will be very high. It's like, imagine that you are sitting outside the door of a closed room and trying to hear what's being said. So I am just giving you that the development of brain-computer interface will go crazy if
yeah,
Neuralink being approved. It's now being tested on humans. I mean, it's being past testing on animals, being now tested on humans. But not to diverge, I'm using electrocamography, EEG. It's a brain headset that you need to wear. Nothing gets inside you. Just wear it, and then we record the brain signals. There are different technologies. It's not just the visual, the one that based on the visual cortex. Because, for example, there is the steady state visual evoked potential. This is something like, okay, what's your response of seeing a picture of giraffe? I don't know, or a lion. So this requires the feedback on a photo, you can say, and that's why there are speech recognition in BCI has been developed based on, like, you have a keyboard, and of course they train the system. What's your brain signal when you think of A, B, and C and D, and you can try to write with just brain signal. And this is being done, in research. It's under research and development. I think there are some stuff in the market, in that area. I'm not an expert in that one, but I think there are. So there are different ways, and I'm using, as I said, the electrocamography, which I am going to show on the next slides. But I just wanted to show you our goal is to help people with disabilities, give people luxurious way to control a smart home, and maybe not to end there. With help of VR, we could have like remote facility management, like you navigate in a facility in VR, and you just think about something and it happens. Okay, this is the ultimate goal, but that's our hope. So
sorry to interrupt you, but if you can go back a couple of slides, in the person with a wheelchair. So because a lot of people are gonna ask, what's the hassle of doing all of that and doing all of this research and spending all of that time and money on something that basically I don't need to control the mobile phone, or my mobile phone, or my lights, or my door, or my windows with my brain. Why would I do that? I don't need it. So imagine something like that. How important would it be to maybe like a blind person, or like a person who is handicapped in a wheelchair? So these things are revolutionary to them. So it's not just like a prosperity of being able to close the lights with your mind, or open the doors with your mind. It's like very helpful technologies that can develop our culture as humans. So just wanted to add the point.
Yeah.
Sorry to interrupt. Yeah.
Yeah, sure. But the most comment I get, okay, Alexa can do that. The point is, yeah, there are people handicapped, but they can still use their hands. There are people that can still use their voice, but there are people who have paralysis that they cannot use pause. The point is, okay, that if we talk about the segment that really would benefit from that, it would be the people who have paralysis that cannot speak and so on, and it's also a big portion. It has a big portion of number. So, but again, my opinion might be a little bit different. I see that will supersede voice interface in some point in the future. It might not be now. Of course, we're still early at that phase, but at least for now, we want to help people with disabilities that cannot speak or use a remote control or something to control their smart home easily. So that's the idea.
Yeah, that's that's perfect. So can you
Yeah,
take
sure.
us in
I
another
want to
walkthrough
continue.
in the yeah.
Yeah, so basically, we have done some research. We have seen the patents and what is in the market and so on. So basically, there are people in research has done some efforts, but the problem is always the limitation of the number of mental commands. Okay,
Yeah.
so what does that mean? That you have like 5 commands, 6, maybe 7. You have limited amount of commands. And imagine if I have a door and a window, probably I will have like on off for each one. Okay, so that's very limited. I cannot do more. So that's what we found out. Okay, and I said, okay, let's try to develop that. Okay, and prototype this and see how digital twin can maybe solve the limitation. So let me give you an idea. And so basically, that was my prototype. This is the physical model. Was a microbit controller. It has different actuator, different sensors, fan, lighting, so on, automatic door opener, a window opener, and so on. I have a mini PC, and I used mini PC instead of Raspberry Pi as a middle point to parse the print signal and so on, decode it, and send the command with a Bluetooth via web Bluetooth to the physical model. The first trial was to control directly the physical model. Of course, as I told you, you need to calibrate the headset. And there are already a software from the hardware provider that helps you in calibrating it and so on. There is also software that help you even to train the commands. You don't need to deal with programming in this part because I'm using the emotive product, but I can tell you there are also different providers that provide you with some easy GUI to do the machine learning stuff that you might be not willing to do. So basically, it gives you a list of mental commands. Here I have only limitation of 5. One of them should be the neutral state. So imagine, I have programmed 4 mental commands. That means like I can open and close a door, open and close a window, and that's it. So that's the problem, the limitation of mental commands, which is why we do have a limitation of mental commands, just to give the audience idea. The hardware capabilities as well as the classification algorithms accuracy. So that's why we do have this limitation. Of course, the more you spend in the hardware, the more mental commands you might be able to program, but still a limitation. You cannot program mental commands for unlimited. That's nothing there. So I did the experiment. We can control open and close the door and window, but it's limited. That's the problem, limitation of the commands. Now I decided to to develop a digital twin. As you see, I don't know if you cannot hear the voice, but I can talk better than. So this is the digital twin. As you can see, I developed it with Autodesk Platform Services, with the Viewer SDK and Data Visualization API. It's a web application written in Node.js. So as you can imagine, these in red are the actuators, the servo that will open or close a door, and so on. So that was the first start to have a digital twin. And the digital twin have connect with the physical model via web Bluetooth, and it's going in a bidirectional way, so I can get some values from temperature sensors and so on, blah blah blah, from the microbit controller, and I can send the control command to the microbit controller from the web application. So like, okay, I click on the door, I can open, close, and so on. Yes.
Yeah, of course, we have a demo. Go ahead.
Yeah, I just wanted now to show you. So basically, this is the physical model, and I have here the lighting, I have a temperature sensor, motion sensor, I have a steam sensor, I have a fan. That's basically the physical model where I run my experiment here. There is the power unit and the gas sensor.
And thinking about what you mentioned earlier about the limitations on this type of technology is like the amount of orders that you can give to remotely to the digital twin. So would it be possible maybe in the future like to work in more than one parameter, like not this specific signal means like open, and plus this another specific signal that means like door. So and the computer or the model can understand that both of these signals together can be merged into to closed door or open window. Can that be possible, or that it just to be have
It might
one
be
parameter
complex.
means?
I got to what you are thinking of. There might be different ways to resolve that issue, but I have found the way via digital twin. That's the one I'm going to show. But of course, there might be some help of another thing. Of course, when I am on my wheelchair, I'm in the living room. That I can filter my choices. But again, it depends on the needs. Okay, what if I want to open a door in another room? That's why what I thought the digital twin could give a real potential in that, because what we are going to see now is a digital twin. I'm now I will connect via Bluetooth and show you how I can open, close door, windows from the digital twin. But this is the intermediate step. You will see how I connected the brain signals later on. So, just to give you the audience, now I'm connecting via Bluetooth, pairing the digital twin app with the microbit controller. You will see a smiley face means that okay, the connection is successful. And then I will start clicking on the servo and send open and close commands. So basically now I'm going to click here and close the window. So I'm sending a web Bluetooth signal with a specific command to the servo, to the microbit controller, and the microbit controller sends to the servo to control. And now I'm going to show that on the door, like open and close. The door is a spiral, as you can imagine. So in this way, I could train. I could program unlimited number. I could add a lot of things in the digital twin. But the problem will remain that the digital twin requires an expert to sit on the computer who can deal with this 3D. And this is not going to be helpful for people with disabilities. So what we could do is to get the brain signal, controlling the digital twin, navigating in the digital twin, let's say, and the digital twin take care of the control. So, and then I just need the brain computer interface to navigate the digital twin, and this makes more easier. But of course, you need the visual feedback, and that might be another problem if we are going to deal with deaf people. The blind people who cannot see. That's another story. But that's the idea. that made me able to resolve that issue, you know. So, and again, I did here some experiments. It works. So the idea basically is that we have a tree that we can navigate, you
Yeah.
know, like thinking up, down, right, left, and then navigate from bedroom to living room. And then I go inside. Okay, I need to go to the door. And then I
Perfect.
go inside, open or close.
Yeah.
So imagine that you have on your remote control for the TV, you have 4 buttons, but you
Yeah.
can switch 1,000 channel, you know.
Yeah.
That's the idea. It's having like a remote control by
Yeah.
print signal with a visual feedback. So
Yeah.
that's
That's a
the idea.
very, yeah, that's brilliant. Yeah.
Hmm. And the digital twin helps here. So that's the idea, or the, let's say, the innovation in this part. So to help navigating a digital twin with just a print signal and seeing the visual feedback in front of you. But
Yeah.
again, as I said, it requires both. You know, you need to see the what you are doing, and it's good also feedback, because
Mm.
whatever, of course, the accuracy is another point to discuss, but at least you can see what you are doing. The
Mm.
system can give you some insights before taking an action, you know. It's even, and this is work under progress, you know. What I'm trying to do also, all the system can recommend you maybe some decision support, you know, like, okay, to preserve energy, I need to close the fan in room number 3, I don't know. So
Yeah.
the system can give you some recommendations as well,
Yeah.
and you can decide with your sprint signals. Yeah.
Yeah. That's perfect. Yeah. And I
Mhm.
really have a lot of ideas and questions to discuss with you, but unfortunately we're running out of time. So
Yeah.
just to sum up, can you give me like a brief about um, uh, how the role of digital twins can evolve in the next decade or something in general, and how can affect the construction industry?
Yeah, basically, I think the digital twins are going to develop rapidly with the help of AI. We started to hear the term cognitive digital twins. We are not hearing digital twin. I
Yeah.
mean, in research, of course, digital twin is now
Mm,
booming in industry, but
mm.
the cognitive digital twins is really the new generation, because having
Can you give us
AI.
an explanation? What is
Yes.
a cognitive? Yeah.
Cognitive digital twin is a digital twin basically which able to be integrated with AI and machine learning and so on.
Yeah.
It's a digital twin that can think and take decisions, support you in somehow.
Yeah.
So this term is being booming at the moment, and I think it's going to be booming in the industry soon. So I think definitely that digital twin are going to be developed further.
Mm.
We have unfortunately a lot of definition of digital twin, but a digital twin for me is something that you can real time monitor and control. You know, it's not.
Exactly. Yeah.
There are different level, there are different scenario, but if you don't have sensor, you don't have data. It's
Mm.
not for me a digital twin.
Mm.
Of course, it depends on which phase are you talking about. Are we talking about operation? Are we talking construction design? But digital
Yeah.
twin without sensors, actuator, from my point of view, is not a digital twin.
Yeah. Exactly. Yeah. So
Mhm.
a couple of last questions.
Yes, please.
Um, as you mentioned, there are a lot of um, like definitions of digital twins, and a lot of softwares are being developed every couple of months. We see after the evolution of AI, we see a lot of software. So um, a lot of collaboration, I think, is needed in the future. So do you think that is this collaboration between software companies and you and the new technologies is important, and how important is this collaboration is going to drive the advancement of technology in construction in the future?
First of all, the collaborations is really important to advance in the area of EC tech. You know,
Yeah.
if we're talking about EC tech, definitely the collaboration is needed on multiple levels. Talking about people who has CS degree, people who have already the domain experts, and so on. And the evolution will be in having this interdisciplinary profiles. That this split might work for a time being, but sooner or later, everyone, I see the future is more interdisciplinary. That's the way I think it is, and I think collaboration is really needed across multiple let's say experience domains and so on, so that we can achieve more better EC future.
Yeah, that's perfect. Hey, do you have any last words for maybe advice, maybe for young passionate engineers, construction engineers, or computer science engineers that want to take a track similar to yours?
That's the difficult question. But when I imagine back, if I would give myself an advice, if I'm now sitting, in third year, doing architecture design in the lab, sitting on the drawing for hours and hours, you may love architecture. I wasn't much loving architecture as I was loving to program at that time. But I would definitely advise myself to start looking for my passion sooner. So it's like, if you think you want to do something there, just start taking a summer school, join a boot camp, do something, building a portfolio. It was a requirement for architects. I think it's now a requirement for everyone. Doing
Exactly.
a project, even in EC Tech. Okay, start building a project, start prototyping, build something on GitHub, develop something. Show your project differently. If you're an architecture student, why not showing your project in VR? Do some innovative stuff. You still do the design, you still do extra points, you learn something, you have a competitive edge, and you enjoy the journey. That's what I can advise. I mean, if you are a graduate, fresh graduate, try to join an internship, or maybe do postgraduate studies in CS, or let's say interdisciplinary domain. That's what I can give as an advice. And of course, gain experience, work in the BIM fields. If you are not being seniored by software developer, try to propose software development. Try to propose ideas. Even if you know Revit well, why not using Dynamo today? Do some visual scripting stuff. Write some Python. Write some C#. Okay, now it takes to the next level. Learn C# professionally. Man, Revit API. Learn Revit API. Do it. Automate jobs. Get credit in your workplace, and then move to the next phase. Okay, cloud is booming. Learn some web development. Do learn then ABS or Autodesk Platform Services to build some cloud apps that you can transform your Revit plugin as a software as a service, and you can sell it, get subscriptions. The future is open in the AEC tech, and the sooner you start, the better. The wave is started, and if AI is moving rapidly and giving us uncertainty. For me, there is uncertainty. I cannot say what happens in 10 years, bro. It's crazy, because the rapid development of AI is quicker than anyone thought.
Exactly.
Yeah.
I 100% agree that it's said that any field or any industry that's not has a background or has a door through software development or computer science, it's eventually going to decline over time. Anything that doesn't has like a path through a web page or a mobile application is going to decline. Things like radio or newspaper, a lot of industries like that are dying because they don't have a window through computer science. And I unfortunately we ran out of time today, so I just want to say, like, I was very, very happy to have you today, Ahmed. I was very excited about our meeting, and I'm sure we learned a lot. Yeah, we learned a lot from you and from Demo, and of course we're gonna do that again one time. Yeah, please make sure to subscribe to our podcast channel, and if you're on YouTube, of course, and join our community on propticbuzz.com. So yeah, till next time.
Yeah, thanks a lot, Yab, for having me today. It was my pleasure. I hope the audience learned something today. Yeah, see you next time, hopefully.
Next time. Till next time.
Thank you very much. Bye-bye.